Going on, guys? In this video we are going to see how to solve Bernoulli's equation. And first of all, you have to know how does Bernoulli's equation look like. The standard form look like this: y prime is equal to a of t y plus f of t yn. So this is y prime, a function of t, and here if you look at this one, we have function of t, and sometime there will be no function. It's okay, but this power should be greater than 0 or 1. And here if you notice, this is 3, right? So this is definitely a Bernoulli's equation. Then after you figure out its Bernoulli's equation, what you have to do is you have to try to bring this into standard form. So we know that this is our standard form, right? So let's go ahead and change this one into standard form. So this is going to be t square y prime, and I move other things to the other side, minus 2 ty plus y cube, right? And here if you notice, in the standard form we don't have anything in front of this y prime, so we have to get rid of this t square, right? So to get rid of that one, what we do is we divide everything by t square, and that's going to give us y prime is equal to, here we can take t square common, so this is going to be minus 2 ty plus y cube over t square. So this is what we are getting, and this is what also other we can just simplify this one, right? Instead of writing like this, we can just simplify, like we can cancel this t, and that's going to give us minus 2y over t plus y cube over t square. And after that, what we have to do is we have to try to bring this into this pattern, because if we bring this in this pattern, we can use the linear first order differential equation pattern to solve this equation. Now in order to do that, we have to pick a n value. N value is basically this one, this y highest power, that is our n value. So here n is 3. After we find the n, all we have to do is plug this n value in this equation and write everything in terms of z. So here what we're going to have is z prime is equal to 1 minus n. We know that n is 3, so this is going to be 1 minus 3, and then here we are going to have the function of t, right? So here we have the function that is negative 2 over t, and instead of this y, we replace that one with z. So here we are going to have z plus then 1 minus 3 again, and then f of t, the function of t. So here we shouldn't write this y, so we just have to write the function of t, that is 1 over t square, right? So this is going to be times 1 over t square. And after we bring this one, what we have to do is let's simplify this one. Here we are going to have negative 2, 1 minus 3 is going to be negative 2. Therefore z prime is going to be negative 2 times negative 2, that's going to be plus 4 z over t, so plus 4 over t times z, and plus here we have 1 minus 3, that's going to be negative 2 over t square. So this is going to be negative 2 over t square. Now this is in linear first order differential equation pattern, and if you remember that in linear first order differential equation, if we have like prime like dy over dx minus a function in terms of x, here we have function in terms of t, times y, here we have z, and that is equal to negative 2 over t square. So this is the linear first order differential equation standard pattern. And if you remember that p of x value, here we have to pick up p of t value. That value is this one, right? That combined with dy over dx and this one. So this value, after we find the p of x, let's say this is p of t, since we have t right here, p of t is minus 4 over t. After we pick up that value, what we have to do is we have to find the integrating factor. And if you remember, if we say mu of t, integrating factor, that's going to be e power integral of p of t dt, right? And we know that p of t is negative 4 times 1 over t, and here what we can do is negative 4 we can take it to the front, and integral 1 over t dt, and integral of 1 over t is ln t, so this is going to be e power minus 4 ln of t, and plus constant. We don't have to worry about constant in this case. And also, to get rid of this e and ln, what we have to do is we have to switch this one right here, and that's going to be a power, so t power negative 4. And also we don't have to worry about absolute value when we do this one, so this is going to be t power negative 4, and this is going to be 1 over t power 4. Now this is our integrating factor. After we find out our integrating factor, what we have to do is we have to multiply both sides of this equation, right, this linear differential equation, both sides of them with this integrating factor. So that's going to give us, let's continue this one right here. So this is going to be 1 over t power 4 times z prime 4 over t z, and minus 2 over t square times 1 over t power 4. Now this is what we have right now. After we got this one, if you remember this first term, like if we write dc, actually dc over dt, right here, this is dc over dt. So what we can have is, or just we can write like z over t power 4 prime. If you find the derivative of this one, that's going to give the whole thing back. So we can just equate, if this is equal to this one, this is equal to this one too. So we can write this one is equal to this one. So this is the only confusing part in the first order differential equation, but it always works, because that's the reason we are taking this integrating factor. That will make this first term derivative is equal to the whole thing. And then if you combine the other side, that's going to be minus 2 over t power 4 t power 2, that's going to be t power 6. Now we have to integrate both sides, and if you integrate in terms of dt, right, dt, and this is going to be derivative and integral cancels each other, so this is going to be just z over t power 4, and in this side we are going to have t power minus 6. So let's write minus 2 t power minus 6, so that's going to be minus 6 plus 1 t power minus 5, right, divided by that power plus constant. Now we can cancel this negative, so this is going to be a positive value. And also if we multiply this t power 4 this side, that's going to become z is equal to 2 over 5t plus c t power 4. But our original form was in terms of y, right? We didn't have z before. We switched it into this one in the middle. So what we had to do is we had to bring this one back. Z is equal to y power 1 minus n. And we know that n value we picked up the 3. So y power 1 minus 3, that's y power minus 2. So instead of c values, we can replace this one with y power minus 2. So let's get rid of some of these parts, because we need space to continue. Okay, now let's continue this one right here. Instead of c, we can write y power minus 2, and that is equivalent to 2 over 5t plus c t power 4. But we have to write this one in terms of y. So this is equal to 1 over y square is equal to 2 over 5t, and if we take 5t common, this is going to become 5ct power 5. Therefore y is going to be equal to flip of this one, y square is going to be flip of this one, 5t over 2 plus c 5ct power 5. Therefore y is going to be equal to plus or minus square root of 5t over 2 plus 5ct power 5, and this is going to be the general solution for this differential equation. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.